So just kind of as a refresher, you have in bivariate data two data sets that you're looking at their linear relationship between. And you have, just like you have independent and dependent variables, AP statistics has to be funky and use different words. We use predicted and response, I think. Did we use response last time? I think we did. But explanatory is just another way, another verb, that's not right, another word to describe one of the variables, okay? So when we look at the explanatory variable versus the response variable, which one is which? Thinking about your X and your Y, if you want to think about it that way, or your independent and your dependent. What's the explanatory? And what's the response? So it says here, an explanatory measures or explain changes in a response variable. Okay, so what does that mean? When we talk about graphing them, which one goes on which axis? Explanatory and response? Other way around, isn't it? The response variable is in response to, right? So this is, think about your independent variable. So response and explanatory, okay? So your response is in response to. It depends on what you're doing here. Does that make any sense? Okay. So look at the note here. Okay. So it says in many studies, the goal is to show that the changes in one or more explanatory variables actually cause changes in a response variable. Okay. We can't do that. We can't say just because these two things are related that one has things, one causes the other to happen, and we talked about that last time. So all we can say is that they are linearly related, is all we can really say. Okay? All right, so I ask you this question because we sort of tried to answer this last class. Is this data linear? It's a multiple stage question. Okay? So we have to think about what we're going to do to answer it. So what are some things that will help us answer the question? How should we start? Okay, we can talk about how we would graph it. So maybe we should create a scatter plot. Okay, that's a good idea. And in a scatter plot, what are we looking for? You're scaring me. It's not I'm not trying to trick you on the question, I promise. What kind of a shape are we looking for? Linear, that's all. Okay, so the scatter plot is going to show something called the form. Okay? And so you need to address that. You need to say, yes, the data is linear. No, the data is not. Or it's approximately in a linear shape, however, but that talks about form. So that's one thing we'll do. There are three things total that we need to do to answer the question. What's something else that we'll need to do? Positive, negative, what? We're not looking, well, we can write an equation if the data is linear, but we really want to find correlation, okay? And maybe that's what you meant by positive, negative, I'm not sure. But we want to talk about correlation. And if the data is linear, what should the correlation be close to? -1 or +1, right? So that's going to talk about the strength. Am I spelling strength right? Is that right? That just looks weird in all caps, I guess. It also talks about direction. Okay? All three of those words, if the question is asked, is the data linear, is important. You need to say the words. There is a positive, strong, positive linear relationship. Or there is a weak, negative linear relationship. So you need to have a word that addresses all three of those things. So strength would be strong or weak, right? Direction would be positive or negative, or maybe no direction if it's weak, right? Most likely there will be a positive or a negative. And then form would be it's either linear or it's not. Okay? So that's what we're looking for. So an example of those words would be strong, positive, linear. Okay? So all three words are important. Yes, ma'am?
You only have 1 and 2. You don't have 3 up there, and I'm wondering what.
1 and 2. Oh, I'm getting to 3. I'm not there yet. Yeah. I'm just talking about the words right now. I promise you I'll get to number 3. Okay? So strong, positive, linear, weak, negative, not linear, I don't know. So those are the kinds of words. All three are important. Some of the questions that I've graded in the past AP exams, if you didn't have all three, you went down from an E to a P. Okay, so that's kind of an important, that all three words are important. So everyone wants to talk about what's number 3 about. So what's the third thing we should look at in terms of is the data linear? Those help us describe the words that we're going to use, but there's one more plot that we need to talk about. Residual plot. So remind us what a residual is. We talked about it last time, for those of us who remember, but it's been a while. It's been about 10 days. What's a residual? Yes. So it is the vertical distance from an observed value to a predicted value. And the predicted value is on the line of best fit, and the observed value is like the point. So for example, if you have this data set, and there's your line of best fit, you have some values that have a positive residual, and you have some values that might have a negative residual. Okay? The line of best fit does its best to minimize those residuals, doesn't it? That's what the purpose of the line of best fit is. And those residuals should be, the sum of all of them together should be approximately what? 0, because you'll have some positives and some negatives. Okay? So that's not the actual residual plot. This is just an example of what a residual might be, what the number residual might be. But what are we looking for in a residual plot? In order for it to be, yes, the data is linear, what should the residual plot look like? If we're going to say, yes, the data is linear, the residual plot should look like random. Random, no pattern at all. And if the answer is no, the data is not linear, that means that there is a pattern in the residuals. When you graph a residual plot, what goes on what axes? Remember we did this? We did it all on a calculator, I think, before break. And we graphed, the residuals came up. It's x's versus the residuals. So you're going to make a plot versus your list 1 versus your residuals. Okay? So in other words, your plot's going to look like, I don't know, that would be a yes, there is no pattern. I'm trying to make it really random. There we go. Okay? So that's what it would look like for how do I graph a residual plot. So I'd like to take this data, and I'd like to see if we can answer the question, is it linear or not? Okay? So I'm going to go ahead and pause for a second. You can use your calculators. I'd like for you to create a scatter plot. I'd like for you to calculate the correlation. I'd like for you to graph a residual plot, and let's kind of put it together and be able to answer the question yes or no. Okay? So let's practice and see how much we remember. So what do you guys think? Is it linear, yes or no? Was there a definitive answer to that question? Is it really strongly linear? No. Okay? So I picked that way. I picked it on purpose that way because you could probably answer this in multiple ways. It's the evidence that supports your answer that's important. Okay? So let me go ahead and just start by creating a scatter plot pretty quickly. We'll turn it on. We have a scatter plot, 1 to 2. We're good, and we'll zoom stat. Oh, what happened there? Oh, is there something in my y equals? Ha ha ha. I have plot 2 turned on as well. Let's try it again. Zoom step. Oh, Zoom 9, not Zoom 8, Kristen. Okay, there we go. All right. So is that kind of what your plot looks like? That looks cubic to me. Would you agree? It doesn't really look linear to me. But let's see how linear it could be. Could we straighten it out? Are there things that we could do? There's probably, we're going to talk about that later on in the week. Maybe even, I don't know how quickly we'll do it, but anyway. So maybe, let's go ahead. So my form, so the question I'm asking you is does it look approximately linear? You could go with maybe it's linear. I might say it looks more cubic, right? But we'll see. So what's the next thing that we need to do? Calculate the correlation. Question first, Justin. Am I missing a point? All right, let me look. What am I missing?
120 and 187.
Oh, I don't have the first two. Well, that's a problem. Thank you, Justin. All right, so it doesn't matter where I put them, right, because I'm not worried about order. So 120 and 26, oh, not 120 and 187, right? And then 26 and 30. And we never sort bivariate data, do you agree? Never, ever? Okay, because they're pairs, they go together. Okay, so let's try that again. So Zoom 9, okay, that looks a little better. Not quite as cubic, would you agree? Okay. So this is very interesting in terms of the data. Are there some points that maybe are strange looking to you? So this has come up in a question in the past on a free response question or a type question where I've seen and released that says circle a point that might be influential. If you were going to circle a point that influences the line of best fit, which one would you circle? I would circle this far right one. Because isn't that going to pull the line of best fit towards it? Outliers and influential points pull line, they're very influential, right? They pull lines towards them. So if I'm talking about form, I probably need to say it's approximately linear with a possible outlier at whatever this point is over here. Could we identify what it would be? 187.30. Would you agree? Far to the right and up. So I would say that if we took that point out, how different would it be? But let's leave it in. So let's just go ahead and say that that's probably an influential point or an outlier there. It's away from the data set. It bothers me that it's there, but we'll look at it. How do I calculate correlation again? Use the calculator to do it. What do I have to have turned on? In your mode, you got to make sure your diagnostics are on. Diagnostics are on mine. Make sure that they're on yours as well. If you ever reset your calculator, the memory, and I believe it has to be reset before you go into the AP exam, the default is off. Just so you know that. So you will have to turn it on at some point during the exam. Okay? And I can't tell you to do that. So we'll just go to stat calc. And remember, there are a couple of linear regression equations. I tend to use the second one just because that's the form AP likes. No big deal. And we're going from list 1 to list 2. We can store it if we want. I'm just going to go ahead and calculate it because I'm more worried about the correlation. What do you notice about the correlation? Think about the words that you need to use based on the number. Stat, calc, any linreg option would work. What words am I using to describe? Positive. We're going to say the word positive. I agree. Definitely positive. And what would you say? I wouldn't say strong. 0.7947. Not quite 0.85 or higher. 0.8. I mean, I would say it's if you're going to say strong, you better use the word relatively. How's that? Okay? I wouldn't say strong. If you take that outlier out, it gets much stronger. I'm going to show you that in a minute, okay? But yes, I would say it's a relatively weak, strong in there. Positive, important to say, linear relationship. Okay? But let's look at the residual plot. Okay? And let's see if the residual plot matters. Or it has an effect on our answer. Okay? Because if the residual plot's patterned, then something's up. Would you agree? All right. So it's important before you do the residuals that you plug in the, you don't have to do it by hand, but you plug in the line of best fit first, because it uses the most recent regression, no matter whether it's quadratic or whatever, it uses the recent one to calculate residuals. So if we go to stat, edit, we want to calculate those residuals. Does anyone remember where we found those? I think if I remember, my calculator up here doesn't have the option and only some of them do. Is that correct? It's in list, but only some of them have them. So it depends on the version of the calculator. I believe mine did. Okay. So if you go to second list, go to names, only some of the calculators had that on there. So just check to see if yours does. Okay. So you go to second list and then scroll down to names. It should be the last one. Okay. Yeah. So second list. So list is above stat. And then scroll down. Okay. And hit enter. Now be careful, because look at where I highlighted. You're telling it to put all of the residuals in list 3. Do you see where my L3 is highlighted there? Do you agree? And then it's asking at the bottom, it's like, you want me to put the residuals in there? You'd be like, yeah, huh. And you press enter, and it will do it automatically for you. If you watched the video from last class, I believe we did it by hand, where we actually used the line of prediction to find our predicted values, and then we subtracted our observed minus our predicted to find those. I'd like to graph the residual plot. So how do I do that? So I'm going to go ahead and go to residual plots. I'm going to turn plot 1 off because I don't care about plot 1 anymore. Is that okay? I'm going to care about it, but I don't want it to go away. And then I'm going to go back and I'm going to turn plot 2 on. And let's make plot 2 our residual plot. In our little synopsis of how to graph a residual plot, what did I say we had to plot? Our x's versus our residuals, right? So it's our L1 versus L3. Look, that's what we must have done last time, because that's what I have still saved in my second scatter plot. And then we'll resume. What would you say to this residual plot? I don't think there's enough data points to really say definitively that there's a pattern. One of the patterns that does come up in residual plots is this pattern. So we have to be really careful when we use a regression line for prediction. Okay? So it's important that we talk about extrapolation. So in this particular case, in your monopoly problem, predict the cost of a new property that is 50 spaces from go. What's the problem with that? Well, it's off the board, first of all. Do you agree? Which means that it's going to be a case of extrapolation. Okay? Go ahead and do it, but you need to address that in your answer to number 6. Fair enough? Okay. Basically, what it's saying here is that we should not make predictions using values of x that are far outside of our data set. So number 6 is a classic case of what not to do. That makes any sense. Okay. Perfect. Such predictions are not accurate. Not going to be in this case. Let's talk about how to do it by hand. The equation by hand. Okay? All right, let's do our original data set. So what was our original? We have the original data set in our calculators, don't we? Okay. Let's do it with the outlier. So Kathy, do me a favor and take that point. Make sure you have it outside, without your outlier. So go ahead and delete on your calculator. Go ahead and delete the outlier for me. Make sure you have that point off. We have calculated, we know what the answer should be. The answer should be this. I'm going to show you how to do it by hand. So the answer we're looking for is 9.7 and 0.145. So obviously we need to put in our variables there eventually, but we will. So how do I get those numbers? Well, you have formulas on your formula sheet. They look a little bit different here. This is our what numbers we have, our B naught and our B naught, and this is our B1, right? So we have B1 and B naught because this is with our formula sheet. We need to find these by hand. Okay? So we need to find correlation, and then what's Sy over Sx? Standard deviation of y over the standard deviation of x. We also need to find the mean of x and the mean of y. Okay? So you need to be able to do these by hand. So what we need to do is you're going to need to find all of these things. Let's do that real quick. Standard deviation of y, standard deviation of x, the mean of y, and the mean of x. How do I find those things on the calculator? I wonder if you can do 2 more steps. Let's try it. So let's go ahead and go to stat calc. See if we'll do both of them at the same time. So we're going to get our x's in list 1 and our y's in list 2. And it gives us our x bar of 128.86. That. And our sx as 24.038. And then we're going to do the same thing if we scroll down to y. Y bar is 28.43. And our sy is 3.69. Okay. Using those 4 numbers, we also need our correlation. You remember we need this number as well. So if we go back, and we go to stat calc Lindbergh again, we'll find our calculation, our regression, 0.9458. With those 5 numbers, you should be able to simply plug them into the formulas and find your slope and your y-intercept. Okay? So let's just really quickly, in our last 10 minutes or so, make sure that this works for us. So 0.9458, and then we have 3.69 and 24.038. If somebody would multiply those for me to make sure that we do, in fact, get a similar number to the calculator. We should get about 9.7. No, I'm sorry. So we get about 1.45. Yeah? Oh, 0.145. Thank you, Brady. So does that give you about 0.145? Why might it not be exact? Rounded. Okay, because we rounded all of those numbers, right? So we just want to make sure we're going to get close to what the calculator gives us. How do I get 9.7? Excuse me. 9.7 is by using this formula. So we're going to plug in the y bar, which is 28.43 minus what we just found times our x bar. And that's going to give us our y-intercept. So we should get close to 9.7 there. Hopefully we did. Okay. So this is calculations. I know it's kind of boring and simple because your calculator can do it for you. But when we get to some review questions, you'll see why that is important. Okay? So I think what I'd like to do is I initially was going to have your quiz next class, but we didn't get to R squared. So I'd like to postpone our quiz to next Monday. Is that okay? We need to get to R squared. So what's due next class is this monopoly assignment. Is that fair? So we'll do that. That'll get turned in. Try to make your scatter plots relatively neat. And then we will finish R squared, and we'll come back and look at those and take our quiz on Monday.